Hello again, Year 9s. This time we're going to keep talking about our expanding and factorising. We're going to be talking about perfect squares and difference of two perfect squares. So perfect squares and dots, we've been talking a bit about that. I might just change, well, apparently I don't know how to change this. Okay, right, we'll write a bit thinner. Alright, cool. So, there goes the bell. Yes, clearly I'm at work and lunchtime just finished if you were here, but you're not here because it's a public holiday. Okay, so perfect squares is when we have two of the same thing, okay? So if we're talking about, let's say we have x plus 1 squared. So we're going to say we're taking the same thing and doing it twice. So remember, squared means times by itself. So another way to write this is like this, isn't it? Because we're saying it's the same thing twice, this multiplied by this. And then you just expand it like you normally do. So whoa, oops. This x needs to be multiplied by both of these parts. So we end up with x squared plus x, because 1 times x is just x. Then we're going to do the same with this part. So 1 times x is another x, and 1 times 1 is 1. Now let's see what we can combine. We've got no other x squareds. We've got two x's, so let's put them together, and we've got a 1 on the end, okay? Now, this is what we call, so our perfect squares rule really means, so we're going to have, if you've got a plus b squared, our rule is a squared plus 2ab plus b squared, okay? So I'll show you, so if you have a look at that, so we've got a squared, which was, so our x up here became x squared, just like a becomes a squared. We've got ab, so a times b, so, you know, your x times 1 is x, and we've got 2 of those, don't we? So we have 2 of a times b. We've got 2 lots of 1x. And here we've got 1 squared, which is just 1, which is our b squared. Okay, let me give you another example without using ones. It might be easier to see. Let's say we'll do y plus 4. Okay, that way we might be able to see it a bit better. So another way to write that is y plus 4, y plus 4. Now, if you've picked up on what our perfect squares rule is, you're going to know what the answer is going to be. Okay, you're going to know that it's going to be y squared plus 8y plus 16 because anyway, I'll go through the answers and then if you can pick up why that is. Have a look at this other rule and see if you can figure that out while I show you how to work it out. Same thing, we're going to start expanding. So we have y squared plus 4y. Then we've got here 4 times y and 4 times 4. So we have another 4y, whoops, and oh, why did I do 8? 16 is 4 times 4. Okay, so then we end up with y squared plus, we've got 4 lots of y here and another 4 lots of y here. We have 8y and then we have 16, okay? Which is what I said it was going to be. Yay! Okay, let me tell you why. Because we've got a y here, so we square it for the first term. We've got a 4 here, so we square it for the last term. Okay, so we've got those two. They're easy. That's just the y squared and the 4 squared. Now this middle one, pretty much what you need to do is take this 4 and double it. Because we want 2, as we saw over here on this other page, 2ab. So we want 2 lots of this times this. Okay, so you pretty much need to double it for the middle term and square it for the last term. If you have a look, let's turn the page and do an example with some negatives. Okay, so let's say we've got m minus 3 squared, okay? Same thing, it really means m minus 3, okay? Now we're going to do the same thing. So I'll give you 5 seconds, see if you can figure out what the answer is going to be just by using the rule, and then I'll show you. All right, let's start with the first bit. So m times m squared. M times negative 3, minus 3m. Now let's do the first one. So negative 3 times both of them. Negative 3 times m is another negative 3m. And negative 3 times negative 3 is 9. but it's a plus 9 because we've got two negatives. They're cancelling each other out. All right, so we still have m squared, and we add these two things together. We've got negative 3, and we're taking away another 3. So we end up with negative 6m and 9, okay? Now, this one here, this is a negative sign because we've got a negative sign up here. But if you notice, it follows the same rule. So it's our first term squared, m. Our second term squared, negative 3 squared, is 9. And our middle term is just twice what this is. So it's negative 6. So it works the same way for negatives as well. So try and keep that in mind when you're talking about perfect squares. Now let's look at dots. Remember your difference of perfect squares. So this isn't quite the same. This is what we're saying, well, actually, we'll look at the rule first. So a plus b, a minus b, equals a squared minus b squared. Because if you have a look at, let's pretend we haven't done this line yet, and we'll just expand our brackets the way that we normally do, okay? So a squared plus ab minus ab minus b squared, okay? That's just our normal expansion. If you see we've got positive ab here and negative ab here, they cancel each other out, don't they? Because it doesn't matter what these numbers are. Plus 4 minus 4 is 0. Plus a million minus a million is 0. So it doesn't matter what these numbers are going to be. They will cancel each other out, and you'll be left with a squared minus b squared, okay? So if you ever see something like this, you can quickly recognise it as dots and know what the answer is going to be. Let's do an example. So if I say, whoa, why did that stop working? That's not good. X plus 7, x minus 7. Okay, so we know that the answer will be x squared minus 49. Or another way to say this is x squared minus 7 squared, because 7 squared is 49. Okay, so it's not minus 7 squared, it's minus 7 squared. Get the difference? Hopefully. Okay, so because if you wrote it out, you would say x squared minus 7x plus 7x minus 49. And these two bits cancel out, don't they? Because negative 7x plus 7x is just 0. So x squared minus 49. So this is dots. This is always dots, okay? Let's do another example. Let's say y minus 10, y plus 10. The answer is going to be y squared minus 10 squared, okay? Because if we expand them properly, we've got y squared minus 10y plus 10y minus 100. These two bits cancel out, don't they? Negative 10 plus 10 is 0. So y squared equals, y squared minus 100. You know what I mean. Let's try and rub that out. There we go. That's a bit better. Okay, much better. So dots is really easy to recognize. If you start to look for it, you'll find it in a lot of places, but a lot of people forget to look for it, and then they go through all of this, and then they realize at the end, oh yeah, that was pretty easy, but they've forgotten to actually go through it. Okay, so I think that'll do for that. Oh no, let's do another one where we have more numbers at the top. Let's turn the page. All right, so let's say I did it like this time. So 2m plus 3, 2m minus 3. Okay, so this time we've got a number attached to the letter, but the same thing applies. Let's expand and I'll show you what I mean. Okay, so let's do the first one. So 2m times 2m, 4m squared, 2m times negative 3, negative 6m. Okay, 3 times 2m is 6m, and 3 times negative 3 is negative 9. See what happened? These two bits are going to cancel out again because negative 6 plus 6 is 0. So we have 4m squared minus 9, which is exactly what we had before. We've got this squared, which is 4m squared, because we've squared the 2 and we've squared the m. And we've got this squared. So it's still this minus this, isn't it? So the square of that minus the square of that. It still works, okay? You just can have another letter attached to it. I mean number. You know what I mean.